Hello, this is another section in Chapter 4. We're still in Chapter 4 in your manuals of the Plant Level 2 certification class. And in this section, we're going to talk about moisture content and some other lab tests. Primary tests we're going to discuss are going to be TSR, boil tests, and how to do moisture content of an asphalt mix. First thing we'll talk about is TSR, tensile strength ratio. It's a measure of the strength loss resulting from damage caused by stripping under laboratory controlled accelerated freeze-thaw conditions. Basically, we're making a couple set of pills. Some set get frozen and saturated and so on. We'll discuss that here in a minute. Other set doesn't, and then you're breaking them and you're seeing a difference of indirect tensile strength measurements. These results can be used to predict long-term susceptibility to stripping of an asphalt concrete mixture. This is the test that the industry uses to predict stripping. Okay, stripping is there to combat the effects of water damage, and there are typically anti-strip additives are used on all our mixes in Virginia. What I'm saying here is VDOT requires you to use an anti-strip. Doesn't matter if it's hydrated lime or one of the numerous chemicals that are approved on the market now, but you are required to use an anti-strip in all your mixes. The dosage for each one is dependent on the particular product you're using, but you are required to use an anti-strip. Causes of stripping. Before we talk about the TSR test specifically, what can cause stripping? Stripping can come from water in the aggregate. Basically, we don't get our mixes dry enough when we're producing our mixes, so we can have water trapped in there. Some aggregates have high silica, such as quartzite. Asphalt binder doesn't bond real well to silica. So if you got a high silica content in your mineral source of your aggregate, then that can be a mix that's more prone to stripping. Dirty aggregates. Basically, if your aggregates are real dusty and dirty, the binder will bond to that dirt or dust, and it won't bond to the aggregate itself. Spontaneous emulsification of the asphalt binder itself. Basically, if your aggregates are wet and not dried before the binder is inserted into the mixing chamber, it would stick on the aggregate that's still wet, still moist, and because the binder is so hot, it basically will turn into like an emulsification. High air voids in the pavement or mat. Anytime we don't get good density in our mats, water can penetrate in, water gets sort of trapped in our pavements then, and then over time with traffic, it begins to promote stripping. Poor drainage on our roads. We never want water standing on our roads. All pavements should be graded so that water flows freely off of them. Things we can do to prevent or minimize stripping. Use well-designed, dense graded mixes. Again, I just talked about compaction. You want your mixes to be compacted well. You don't want no more water penetrating your mix than you can help. Provide the positive drainage, which we were just talking about. You want water to well, I'm going to call it sheet fall off, to freely flow off the pavement. The aggregates need to be very, very clean so that the binder bonds to the aggregate, doesn't bond to the dirt, the dusty aggregates. As far as using hot, dry aggregate, the new addition of warm mix additive in the last few years, mixes sometime will be produced at a cooler temperature, which is great as long as they're still warm enough mixes, or hot enough mixes, might be a better way of saying it, that they are drying the aggregate out during the mixing process, okay? And then this is what we're gonna start talking about now, is the use of moisture sensitivity testing, or basically the TSR. TSR stands for tensile strength ratio. The test procedure for this test is AASHTO T283. In that particular procedure, there's a freeze-thaw cycle that in Virginia you are required to do. Basically, TSRs are now ran during the first lot of production for each mix that's being produced at each plant. Okay, prior to last year, we had to do TSR testing during mix design, but because our binder sources are very constant and our aggregate sources are very constant, we really don't have no new aggregate sources in the state in a long time. We now know that during the mix design phase that, based on experience, that the TSR, how much anti-strip we have to add to get it to pass TSRs. We're fortunate that VDOT realized this is a very long, multi-day test, a lot of work involved when you're having to make your samples in the lab versus having plant-produced material. And the bottom line is, we want to measure the stripping as it was produced through the plant more so than what we've done in the lab during a mix design phase. So VDOT couple years ago, switched to the acceptance when it comes to TSRs, so that our TSR tests are now ran as a production test, which makes it a requirement for the asphalt plant level 2 certification to be done during the first lot. Okay, as we stated, AASHTO T2A3 is the test procedure we use. Test samples are compacted to between 6 and 8% air voids. You target 7. You need a minimum of 2 subsets of 3 for a total of 6 samples. Once you create your 6 gyratory pills, or you can do Marshall pills for this, which uses a lot less material. Once you've created your total group of pills at 7 plus or minus 1% air voids, you need to divide them into 2 subsets, 3 each. All right, for this 3 each, it's important that the average air void content for each subset be as close as possible to matching, all right, to being the same. In other words, you don't want all the high air void content on one side and all the low air void content on the other. You want to have them mixed up so that everybody's about the same. Okay, so that's with once we divided that, 3 of these will be conditioned and 3 are unconditioned. The unconditioned set, you've measured your void content, you're done. You're going to set them on a shelf for a couple days while your conditioned set continues through the process. What happens with the conditioned set is you take 3 of those pills that you've decided that will be your conditioned set, and you vacuum saturate them. You vacuum saturate them between 50 and 80% saturation. Here is one point you have to be careful. You don't want to oversaturate these samples. If they're undersaturated, you can saturate them more. If you oversaturate them, you have to throw that sample away and start the whole process over. So use caution when vacuum saturating your samples. Be careful about the vacuum pressure you put on it. Don't use the same vacuum pressure you do as a rice, even though most likely you're using the same equipment setup. You want to do it at a lower pressure. Once my conditioned set of samples have been saturated, okay, I want to wrap them in saran wrap. I want to put them in, or some sort of plastic wrap that holds the moisture in. I want to put them in a Ziploc bag that I can close up tight, and I want to put them in a freezer. They go in this freezer for a minimum of 16 hours. Typically, people will do it overnight. It can be 16 to 20 hours, just whenever you want to pull them out the next day to get working. But specification calls for them for a minimum of 16 hours, they're frozen. Once your freeze cycle is done on this conditioned set, remember my unconditioned is still sitting on the shelf over here for 24 hours or thereabouts. I'm going to take them out of the freezer and I'm going to put them in a hot water bath. That hot water bath is set at 140 degrees Fahrenheit. Okay? Now remember, those samples that were frozen are in a Ziploc bag or an airtight bag, watertight bag, and they're wrapped in some sort of plastic wrap. When I put them in this hot bath, all this plastic has to come off. They come out of the bag, and you need to remove that plastic wrap. When it's frozen, that plastic wrap's very brittle and it breaks apart on you. I recommend, like you would dunk a donut in a cup of coffee, dump half of it in, it makes the plastic almost fall off, roll it over and do the other half, and the plastic just falls off your sample. You can lay your samples now in this hot bath at 140 degrees Fahrenheit. There they'll stay for 24 hours. Again, my unconditioned set, still sitting on the shelf, haven't been touched. My conditioned set went through a freeze cycle. Now they're going through a hot water soak with water being circulated in a water bath at 140 degrees for 24 hours. At the end of that 24-hour period, these conditioned set of samples will come out and go into another bath that's at 77 degrees Fahrenheit. They'll go in this bath for approximately 2 hours prior to doing the indirect tensile test we'll talk about in just a second. So when I take these samples out of the hot bath and I put them in the 77 bath, these specimens can heat this water up. Most likely you'll need to add a few cubes of ice. I typically would have 16-ounce glass, a cup of ice, nothing but ice in it, and I just dump the ice in that water at that time because I want to maintain that 77 degrees. I don't want the temperature to elevate too much. So when I do that, I put them in the water bath, I'll add a little bit of ice. But at the same time, my unconditioned set of samples need to go in this same 77-degree bath. The purpose of this 77-degree bath is to make sure that the temperature of the specimens I'm breaking are all the same, okay? But I don't want this unconditioned set to get wet. So I will take this set and I'll put them in a watertight Ziploc bag, and I will put them in the same 77-degree bath. So now I've got my 77-degree bath that has 6 samples in it. My 3 that have been conditioned, they're wet. They went through a freeze cycle, a hot water soak cycle, and they're sitting in there with no wrapping. The unconditioned set is sitting in the same water bath, but they're wrapped in a watertight bag, but they're in there to get the temperature equilibrium to the other samples. At the end of that 2-hour period, I'm now finally ready to do the TSR, tensile strength ratio test, which is nothing more, as you can see here in this image. You have a breaking head. This happens to be called the old pine test press. I see these in labs all the time. And this is called the indirect tensile test, or indirect tensile strength measurement on these peels. So what happens is the specimen itself will crack right in half once the test starts. This piece of paper here will create a plot. I don't need the whole plot. All I need to know is the peak strength for this plot. Okay? Some newer pieces of equipment don't even have a graph like this. They just give you a number at the end of the test and it tells you the peak strength. That's the only number you need to do a calculation for TSRs. So I will break all my condition set. When I say condition set, the set that was frozen, hot water soak, and now temperature equilibrium and broken. And then I will do all 3 of mine from the unconditioned set that didn't do all the freezing, didn't have any of that done to them. They were only put in the 77-degree bath. Now I have 6 strength value measurements from this test. I want to take and average each subgroup strengths, and I end up with what's called the TSR ratio, which is the strength of my unconditioned set over top of my strength of my conditioned set. It's a simple calculation, one number over the other number. When I divide it out, I end up with one number. For that, to meet TSRs in the state of Virginia, you have to be a minimum of 80%, of 80, okay? That 80 is the minimum we can have for an acceptable TSR test. Now you can understand why we're very fortunate that VDOT allows us to do TSRs on plant-produced mix now instead of having to do it during the mix design phase, because it's a 3 or 4 day process without having to mix up 6 or 8 samples to get my voids compacted right. So this is quite a benefit to all of us. All right, but this gives us a strength ratio measurement that can predict stripping. And it's the test that we use to predict stripping in the way we reference asphalt mixes in our industry. One other test that's not as popular or used as much that can predict stripping is called the Boyle test. Be surprised how few people, when you talk about the Boyle test, if you ever ran one, you find out not very many people do it. Because this is a much simpler test. The difference about the Boyle test, though, it isn't a definitive number. I got like the TSR, I got like a 92 value that tells me my TSR passes. This has a little bit of opinion involved in it, and for that reason I don't think it's used as much. Used to be when I used to work for VDOT, we used a lot of it as, do we want to worry about running TSR samples or not? We would run these Boyle tests all the time, and as long as they look good, we weren't worried about running TSRs. When we had one that looked bad, next day we'd be pulling the TSR sample. Anyway, this comes from Virginia Test Method VTM 13, and it will predict what is called potential stripping, short-term stripping of asphalt mixtures. To do a Boyle test on a plant-produced sample, you want to first allow your mix to cool to about 230 degrees. All right, once it's cooled down, I need about 800 grams of material that is all ½ inch minus or less. If I'm doing a base or an IM, those larger aggregates have been known to break our beakers, so we just want 800 grams of ½ inch minus material. So you just take a sieve, shake it over, and get down to that quadrant, that amount of material. After we've got that, we want to take that 800 grams, we're going to split it in half. Now we got 400 in case something goes wrong with our test, and the other 400 we're going to use to begin our test. To begin our test, we take the 400 grams we have, divide that in half again. So we got 200 and 200. The first 200 is put on our towel. No work is done to it. It's not boiled. It doesn't get wet or nothing. It's used as my reference. The second 200 grams of mix is put in a beaker of boiling water. The water needs to already be boiling before you add it. Okay, so it's added to boiling water because it's only boiled for 10 minutes. This image here shows a Bunsen burner being used to boil the sample. You can do boil tests with hot plates. I've done it, so you don't have to worry about Bunsen burners and dealing with all that in your laboratory. But you boil it for 10 minutes. At the end of that 10-minute period, you dump the sample out on another paper towel right beside your reference 200 grams. All right, now we want to allow this sample to dry. I think the specification VTM 13 says dry overnight. You can put a fan with a little air movement over it, and it'll dry in a couple hours. You don't have to wait till the next day to get this measurement for your boil test. So just allow your sample to cool, and then basically you're comparing how much binder would have boiled off the aggregate visually compared to your reference sample. It's a visual comparison, and that's where people say it's an opinionated test. Well, I can understand the opinionated comment, but when I see asphalt binder in this beaker like this much binder, that's telling me that beaker was clear when they started the test. Now it's very dark. That's telling me that the binder is coming off. And maybe, in order to quantify whether we're having a stripping issue or not, we may want to move forward with a TSR test on this particular mix in the near future. The boil test is just to look for signs of stripping. If the boil sample shows more stripping, the test fails. That's what we just talked about on the previous slide, that it's a visual comparison between the two. If you do have a failing boil test, it is in the specification that you should run a second sample, just as you did before, to confirm your boil test results. All right, and if that second sample fails the boil test, you're to stop production. You need to go to your plant and say, we are having a problem. We got to check our inner strip. We got to check what's going on, but we're having problems with stripping. And work can't be resumed until you can figure out what you need to do to improve possible stripping of your materials. Now let's go real quickly through the moisture content in the mixture. Content measurement of mixture is nothing more than a determination of how much moisture is in your mix. It's talked about, moisture in mix is one of the biggest problems we have. It's very, very important that we dry our aggregates properly during our mixing process so that the binder bonds as well as it can to the aggregate. We got a little video here that'll show you how this works. Notice here his pan's empty. He just wants to record the weight of his pan for his second weight while everything's dry. Now he's getting a sample weight, 2,045.5 grams. This sample would have been taken right from the back of the truck. It hasn't had time to dry out at all. That's what he's doing now. He's putting the sample in an oven and he's allowing it to dry to a constant weight. This can take an hour approximate. It can take a little bit longer if needed. Notice his sample weight was 2,042 grams, so he lost a few grams. The weight he lost would have been moisture. It's a pretty straightforward, simple calculation we use to calculate moisture. You look at the weight of the wet sample minus the weight of the dry sample divided by the dry sample weight. We multiply it by 100 to convert it to a percentage. There's no limit on moisture for your stockpile quantities. In other words, they can be wet. The problem is with wet stockpiles is you got to dry them out during the production process. But there is a specification limit on the final mix moisture content. In the specification, it states that the mix moisture content cannot exceed 1%. All right, so that's why we're actually doing the moisture content measurement on our final mix. This isn't done as frequent on a daily basis. I mean, common practices, you don't do this all the time. But I do recommend that you do it anytime there's a big rain. In the case of you're producing, everything's going well during the day, been dry for a week and you're doing 2,000 tons a day, moistures aren't going to be a problem in your mix or in your aggregate. But one night you get this major thunderstorm, you get 1.5 inches, 2 inches of rain, You come in the next morning, they still want to do 2,000 tons that day because the sun's shining out and everything's dry. Well, when they fire up, you need to, as soon as possible, check your moisture content. If your moistures are too high, you can do one of two things. One is you can turn your mix temperature up. If you're running warm mix and you're running at a lower temperature, after rain, you may have to boost the temperature a little bit. Option two is to just slow down your production rate. Slow it down, give it a little bit more time to dry out during the mix chamber or the drum of your plant so that it has time to dry the moisture off before continuing. But it's very important, and I highly recommend after each rain, you watch your moisture content of your mix. With that, you got some knowledge check questions at the end of this chapter, and I appreciate your time. Thank you.